So now we're going to move to the EDA panel. So Sergio, if you want to stay, and invite up Bindish, Mark, JL, yes. See? So do we have a question from the audience? There was one we had yesterday which didn't get answered, so I'll say it today. It's from the webinar. In terms of, mainly directed to you first, I think, Bindish, because you're talking about collaboration of Verdi with other tools, but people are very interested to understand Synopsys' view of UCIS and the collaboration around that unified coverage database.
So I'm involved a little bit. I've actually been on the UCIS committee now that Springsoft, and still remain active in it. But one of the things that I would, my ideal goal in the end is to have Verdi or a module of Verdi also be sort of a coverage tool as well, coverage debug, visualization, everything to do with coverage be part of that flow as well. That requires a database. All of our analysis today shows that UCIS is almost there. There's some technical challenges that need to be resolved. We hope they can and we're involved in the committee, so we hope we're part of the solution as well. But the other option is to build our own FSDB coverage database and try and make it the de facto standard, but I think the UCIS avenue is probably better. We have no date on this.
Does anybody else want to talk about UCIS? Do you want to talk about OneSpin's view of UCIS?
Sorry, was the circuit before I missed So OneSpin, as I said, there is this tool Quantify that computes coverage metrics out of a session. So it's a push-button tool. You give the design, you give the session, and it computes coverage. And this coverage information can be popped out in XML to be integrated in your UCDB using UCIS, so to be integrated with your simulation coverage metrics. So we like that. We want to support that more and more.
Okay, next. Francois?
Yeah, we seem to have quite a few changes from different people who presented the last few days, and on the IP to SoC level. So Jerome said he actually required more reuse of the verification IP at SoC level and so on. I've also seen some blogs saying that UVM is not universal in the sense that it's wrongly addressed the system level, and some people are trying to do some real universal methodology. So is there anything that you're saying happening to better verify the SoC level, hardware, software, integration, use cases, and so on, that might happen from the vendors?
Not for me.
It's too bad. Who's here from Doulos that could actually answer that question about easier UVM? So we talked about it before. I mean, UVM is a standard that it's not the ends, it's the means to the end, right? So it's a question of what we do with that and how we apply that. Is that the challenge we're going to find, I think, what we're seeing is that as we move from IP to subsystem to system level types of verification, it's easy to ask the question, how can I reuse all of that information? And certainly there are parts of it that you definitely want to reuse, the verification IP and the connections and the transactors and the drivers and the monitors. There are lots of things you want to reuse, but you're trying to do different things, as you know, as you presented earlier, right? I mean, you have different verification goals at each of these levels, so it's we're looking for some magic solution that says, gee, I verified my 35 IP blocks, so how can I now just take all of that verification together and magically have it verify my system for me when I've assembled all the design IP together in a system? And it doesn't work that way, as you well know. I mean, again, are there parts of the infrastructure that we can reuse at broader levels, not of abstraction, but as we look at the greater system, the greater chip, yeah, there are parts that we can reuse, and the more the better. And that includes, all different types of things, from coverage to different types of metrics to, we were talking earlier in the week about the hotspots in the code, verifying different, analyzing different types of things. And, we're all trying to use the standards to allow you to reuse as much as possible. But, as you saw, there's just different things at the block level. You're not even considering cache coherency validation and coherency state transition coverage. But when you get to the subsystem level, that's really important. And when you get to the full system level, it's also really important to make sure that the software can actually manage all of that. So you traverse up the level of the design, and you have different things that you want to take care of. So in UVM, as we were talking about, it's sort of ironic. It's really not universal in that it doesn't solve all things for all people, but it's universal, I think, in that everybody can use it as a building block universally, and then add things to it to add value. Right. Anybody? Yeah? You want to pontificate?
So I luckily, or for better or for worse, I can't really speak for Cadence on this topic because I've only been at Cadence for 3 months, so I don't know all the positions. But I do know that, so the UVM, of course, having been on the committee, it was on purpose that there's not a complete methodology there. It was a big argument, let's put it this way. Some vendors did not like some other vendors' methodologies, and so they decided that instead of trying to agree on one, they would not agree on one so that they could each go do their own thing. This is what happened. But as far as bringing your testing from the full chip, you can think of it the other way too. Instead of trying to bring it from the block level up, if you think about from the top down and at least having some stimulus that can be run. I did this when I was leading a verification team a couple of years ago. You can think of the top level test, write it at the low level, and then make sure that it comes back up. So it's another way.
Any questions? Yeah? There's one online. I know. So the one online is, there's just two online. I'll give the first one. The first one is, if formal verification is on the rise, one thing that's missing is how to combine dynamic and static. From the question online, how would you suggest to people the best way to combine dynamic and static verification? I guess that's for you first, Sergio. You're a formal guy.
So I think in terms of, for instance, coverage, we spoke about that, and you need the way, certainly a better way to integrate the coverage results with the simulation results to avoid overlap. I think there is also a methodology thing, because as I said in my presentation, sometimes formal is used to improve, confidence on certain parts of a design, but it's unclear what part of simulation you can replace. And that obviously it's a problem because it's more expensive, and you have to do kind of both. And yeah, the managers don't like that. I think that's perhaps an area where we should focus more, to try to be a bit bold and identify and prove, areas where simulation can be replaced. Obviously, formal is not going to replace all simulation, not anytime soon, but some parts can be replaced. That's a key word, replace. It's already people always say, no, it's a bad word sometimes.
Well, I think there are. This is Mark, for those on the phone from Intergraphics. So in terms, this is a big trend right now, is the coming together of formal verification and dynamic simulation. And in some cases, it's just a matter of using what the previous question, or 2 questions ago, around UCIS, and managing the data and the coverage goals and the verification goals and the metrics while we run multiple processes. And we are starting to see formal verification take on some of the tasks that used to be done dynamically, like clock domain checking, a lot of things in the power aware verification, X reset verification. And then we're also starting to, but in those cases we're running both processes, static and dynamic, but they're only coming together at the surface level. They're just coming together by managing the data, by managing the collective goal of verification and using multiple tools, dynamic or static technology to achieve those goals. But now we're starting to get to the point where we're merging the technologies, right? So a really simple application of that is where formal techniques are being used in conjunction with dynamic simulation, as we talked about before, to just help you simply generate an exclusion list of unreachable code for RTL code coverage, which can save you an awful lot of time. It's a pretty straightforward application of the technology, but the benefit is pretty significant in terms of time. And then after I've run the simulation, going back and saying, well, here's all of the code coverage, the code that I did not achieve coverage of, let's use the formal tool to automatically generate waveforms for me that I can use to augment the simulation so that next time around I get that coverage. So we're starting to see sort of some simpler areas of where formal verification techniques and dynamic techniques are working together. One of the areas where we're spending a lot of time, and this is the next level, where we're using formal verification to actually generate the stimulus. So and if you look at the graph-based technique, this is a formal technique where we're using NFAs to model a behavior and then using intelligence to actually simulate, to synthesize or to create sentences from a grammar that are presented to a dynamic simulator. So it's a formal technique to generate stimulus rather than just making random haphazard decisions, but applying them in a dynamic way. So we're all starting to move in this direction of combining the formal techniques and the dynamic techniques. And the dynamic techniques, I mean, the formal techniques are actually, ironically, using that technology is helping to prolong and make the simulation technology last a lot longer.
So I think I'll quickly mention that, I'm probably not answering the question directly, but we do use formal techniques in all kinds of ways, let's say in Verdi, and primarily also in Certitude, right? So in Certitude, for example, for those of you who don't know what it's all about, you can talk to me later, but to find, just like Mark was saying, unreachable states, we use formal techniques for that. Beforehand, to filter out, to reduce the load on the verification engines. The other aspect that Certitude now does is to you can not only use a dynamic simulator as its target verification engine, but also a formal simulator, a formal engine as its target verification engine.
Any more questions from here? Okay. Yeah, thank you. Do you want to say the names? This is Simone Abilis Systems. I think we had this morning, I think it was for Mark, that emulator technology is getting more and more revenues and importance. I think this also is a way of addressing system-level hardware-software verification. And so I think next step, as Mentor presented this morning, is to, for the big EDAs, will be to provide some kind of unified environment in which we can reuse same environment, the same tests to different targets, and so merge also the coverage from them. So I would like to hear a little bit more on how this approach works from Mentor. Maybe what are the plans from the other big EDAs?
Yeah, that is so. That is an area where we're putting a lot of investment in now, and that is in conjunction with raising the level of abstraction and verification. The same way that 20 years ago they raised the level of abstraction in design implementation. Instead of designing with gates, you design with your intent at RTL, and then let the synthesis tools take care of automatically generating the actual implementation. We're starting to do the same thing now in the test space, in the verification space, raising level of abstraction to a graph or to a declarative description rather than a programmatic description. And we're not the only ones doing that. I mean, I can say Breaker, right? They're one of the sponsors of the conference, right? So So Breaker, which is one of our competitors, is also leading in that area and putting a lot of investment. And our understanding is that there are some others, maybe even standing up here, that are investing in that area. But it gives you the ability to describe the behavior of a system that you care about at a higher level of abstraction, and then you can retarget the generation of the test bench and the generation of the stimulus to an emulator or to a simulator or even to post-silicon or even to an FPGA prototype. And again, it's much think like logic synthesis, right, where you can raise the level of abstraction, which gives you the ability to retarget to different implementations, different platforms, and that is the future. It's a half a step closer to, you know, nirvana, what we've called the executable specification, right, where we write a specification in a particular way, we press a button, and out pops the verification environment. You know, we're nowhere near being there yet, but if you look at a BNF architecture and raising the abstraction verification, we're starting to get closer, and one of the things you need to do with these emulators is fill them up. I mean, if you're going to spend a lot of money to invest in verifying at the system level, you want to be able to take full advantage of them by generating lots and lots of tests. But it's a different level of verification, as you identified, than IP block level. And in a perfect world, you're not even verifying the IP blocks, right? Perfect world, right? They come pre-verified. One would hope. But of course, that doesn't always work out that way.
Okay, the last one, which is probably a good question to finish the whole week, is from online. In terms, we've talked a lot about metrics. So from each one on the panel, what's a crazy off-the-wall metric you'd suggest to people to take away from today?
A metric that was discussed today, or a metric that...
Any crazy off-the-wall metric that you think people could be applying that would be useful in the verification management?
Well, my favorite metric is called, it was on my slide, but I didn't talk about it. It's called the truck factor. I don't know if this is familiar here. It's basically how many people on your project would have to be hit by a truck before your project fails. Maybe I need some help. So this way you can decide if there's some one person that's critical on your project and that's the only guy or girl, and they're gone, they're sick, they leave, whatever, are you screwed? That's a useful one to know.
You want that metric to go high? Or
I think you want it to be higher.
Okay.
We'll just decide that.
Less risk if it's higher, I guess, unless there's a mass accident.
Yeah. Yes.
So maybe we can derive a metric from a JL presentation, so everyone could track in every project, say, okay, these are the normal behaviors, these are the rules, how much we are deviating for this, and then, you know, if you don't deviate, then it means maybe, you know, you are not thinking about innovating, or thinking about other ways of doing things, which is bad. So the more you know, kind of deviate for the rules and the set behaviors, the better it is.
Finish?
I'll give a more product-focused answer, but I think Certitude provides the best metric. I think as an overall metric, it's not the only metric. I think as an overall good feel metric, I think it has to be. I think it has to be a necessity in a verification plan. A Certitude metric.
Which one? Say the Certitude metric.
Yes.
Okay. You'll get your pay rise this year. Well, last one. You got one.
I'll just reiterate that the Certitude metric is a great one. I'll agree with you, because what it'll quickly prove is that graph-based verification is the best way to generate tests. So they work very well together, by the way.
Yeah, it's collaboration as long as you buy both tools, I guess.
We work together more closely than you might think.
Did you want one more, Silvio?
I take the opportunity to advertise one thing for myself. So I have a paper coming up on Dutch Design Forum, and they address things like bug avoidance, so designing, avoiding bugs, and working very close to design engineers, so with a different flow. So if you're interested in this topic that we touched today, look out for it.
Okay, so a big thank you to our speakers and our EDA panel. We have some prizes to give out as well. Thank you.